Good morning, children. Let's start with the chapter number 3 of ICSE chemistry, grade 10th. So the chapter name is acid, bases and salts. So here, page number 39, you need to pay attention on the definition of acid, bases or alkalis. Okay, an example of the weak alkali and strong alkali from here can be asked to you. Now here you have next topic, that classification of acids and bases. So in the classification of acids and bases, you should know based on the basis of the first is basis of sources of acids, like from where you are getting. So organic and organic acids which you are getting from plants and animals, right, like oxalic acid, citric acid. Mainly you have in your syllabus acetic acid and formic acid. Formic acid we get from red ants, and acetic acid you are getting from vinegar. If I am talking about inorganic acids which are made up of minerals like your chlorine mineral, HCl acid, nitrogen, HNO3, nitric acid, sulfur mineral is there, sulfuric acid, phosphorus mineral is there, phosphoric acid. The second is based on the molecular composition of acid. Here you have hydra acids. What are hydra acids? Hydra acid or halogen acids we can say, where you will have in hydra acids one of the atom will always be hydrogen. Like if I say write the hydra acid, which one of the following is the hydra acid of chlorine? So HCl is the answer. HCl, HBr, HI, HF, anything. Oxy acid or oxo acid, where you will have hydrogen, oxygen as well as a non-metal. Like if I am asking you what is the oxy acid of sulfur, so the answer will be H2SO4. Sulfur is also there, sulfur is there, along with that oxygen and hydrogen will be there. So in oxo acid, oxygen and hydrogen both will be there. Now next is based on the strength of acid base. Very important point, you should know the definition. That depends upon the concentration of hydronium ion. Strong acid, that acid which undergo almost complete dissociation. Weak acid or weak acid which will undergo partial dissociation. Okay, strong acids examples are all mineral acids are the example of strong acid, and acetic acid, or you can say all the carboxylic acid or organic acid are the example of your weak acid. Okay, in strong acid you will, because they are undergoing almost complete ionization, so what are the constituent particles? Only ions or mainly ions. If I am talking about weak acid, so then what will be the constituent particles? In weak acid you will have molecules as well as ions in the. Now same definition for strong alkali which undergo complete dissociation. Example of strong alkali is your NaOH. Remember this, NaOH, KOH are the example. Or you can say all the hydroxides of group 1 in the periodic table. Okay, and group 2 hydroxides are your weak alkali, like your calcium hydroxide is a weak alkali, magnesium hydroxide is a weak alkali, as well as ammonium hydroxide is also an example of a weak alkali. Okay, so if you have ammonium hydroxide, it undergo partial dissociation, so it will have both ions as well as your molecules in its solution. Okay, so this is one more example. Weak acids examples are given to you: acetic acid, carbonic acid and formic acid, that you need to remember. Next you see that on the basis of concentration, dilute and concentrated acid, that is fine. Okay, now fifth point of classification is also very important. They can ask you basicity of acids. Basicity means per molecule of acid how many replaceable hydrogens you have, right? If you have HCl, you have one hydrogen replaceable hydrogen is present in HCl, and such acids can give you only one type of salt, because because they can displace only one hydrogen. Dibasic acid example is sulfuric acid, H2SO4, two replaceable hydrogen per molecule. And tribasic acid, yeah, here we have a very good example. Remember that in Virapula Dilal book you can see page number 41, two examples are given for this, right? That is your one is phosphoric acid, one is phosphorus acid. Remember, in between these two acid only one is your tribasic acid. Which one is a example of a tribasic acid? H3PO4, that is phosphoric acid. Remember, phosphorus acid is not the example of a tribasic acid, because sometimes you just count the number of hydrogen. H3PO3 is not the example. Okay, they can give you this example. Remember, H3PO4, that is your phosphoric acid is the example of tribasic acid. Okay, tribasic acid can form three types of salts. Next come to for base we use the word acidity, right? So which base is monoacidic? which will have one replaceable hydroxyl group like NaOH, KOH, NH4OH. Diacidic base which will have two replaceable hydroxyl group like CaOH whole twice or magnesium hydroxide. Similarly, triacidic base, that is aluminum hydroxide, 3 replaceable. Okay, so this is something from page number regarding the basicity and acidity, page number 41. Now come to page number 42. From 42 you have the same thing regarding the formation of ions that we already discussed in our chapter number 2, right? Then come to page number quickly. You have indicators. Okay, come to indicators. In indicators you have the pH scale. Your 0 to 7 is acidic behavior, 7 is neutral, pH value 0, pH value 7 is for your pure water, you can say, and then 7 to 14 will give you the basicity. Yeah, that means basic nature of the solution, right? And if pH value is increasing from 7 to 14, it is showing that you are moving from weak base to a stronger base. And in case of acid, how will you read? You will go from higher value, you will go from 7 to 0. That means if pH value is decreasing, your acidity will increase. Always remember, pH is having inverse relation with hydronium ion. Okay, that means pH is high means hydronium ion will be less. This point also you should remember. If you have a neutral solution, how can you increase the pH value of a neutral solution? If they ask you to increase see, neutral solution means pH is 7. Increase the value of pH means you need to add few drops of alkali, right? If I'm asking you to decrease the pH value less than 7, then you need to add few drops of acid to that neutral solution. Okay, so this is one thing. Second thing, here you have two types of indicators, common acid base and universal indicator. What is the difference between universal and common acid? Common acid base indicators like litmus solution and all that only tells you about the nature, that whether you have an acid or a base. It will not tell you how strong acid you have, but universal indicator, that is PS solution, tells us about the strength of the acid and a base, that if you have a acid, whether it is a strong acid or a weak acid, okay, by changing its color. Next is, there is a table which is given in page number 47. Very important, you should know that what is the color of litmus when it is neutral, that is purple color. Okay, and in acidic medium, what color will change from neutral to red? In basic medium, the color will change from litmus color, purple color to blue. Methyl orange, actual color is orange, but in acidic medium, what will be the color of methyl orange? Pink. And what is the color in basic medium? That is, it will change from orange to yellow. Phenolphthalein is a colorless indicator. In acidic medium it will remain colorless, but in your alkaline medium it will change into pink. And sometime they will give you alkaline phenolphthalein. Alkaline phenolphthalein means colorless phenolphthalein, you added some alkali drops. So what will be the actual color of alkaline phenolphthalein? Will be pink. On addition of acid it will turn into colorless, but on addition of few drops of alkali it will remain pink. Okay, so these are some points which you need to pay attention from the indicators. Okay, now just quickly come to the page number 48 about the salts. For first point is definition of salt itself is very important. They can ask you the definition of the salts, or they can ask you, the definition will be there, you need to identify the term. Remember, a salt is a compound which is formed by partial or complete, it can be partial or complete replacement of replaceable hydrogen of an acid by a metallic ion. It can be a metallic ion or it can be ammonium ion, which is also a basic radical, by any basic radical. Sometime they will say metallic ion. Ammonium ion is not a basic, it's a basic radical, but it is not a metallic ion, right? So they can ask you, give an example of an ion which is not a metal but is a basic radical and can be used to form a salt, right? So that is your ammonium ion. Next is acid salts and basic normal salts definition. What are acid salts? Acid salts which are formed by the complete replacement of the replaceable hydrogen of an acid. Okay, so so acid salt will form when there is a partial replacement of hydrogen of an acid by a base. So that means when you have a base in insufficient quantity but the acid will be more in quantity, so since the base is insufficient, it will not be able to replace all the hydrogen. Okay, so one example, yeah, here they can ask you an example, that give an example of a your acid salt. So acid salt will always have one replaceable hydrogen in it. And one more thing, when they ask you name the salt, you can't write the formula. That also very important. NaHSO4, you should know the name, sodium bisulfate or sodium hydrogen sulfate. Second thing, they can give you 4 salts in the form of MCQ. They can ask you which one of the following is an example of a acid salt. Okay, that is one thing. And it is formed by, as I told you, insufficient alkali, because alkali is insufficient. Now how the normal salt will form? It will form by the complete replacement of replaceable hydrogen of an acid by an alkali. So here you have, since you have alkali in sufficient quantity, it will replace all the replaceable hydrogen and you will get a normal salt. In normal salt you will not have any replaceable hydrogen. Okay, so this is one thing. And here acid salt and normal salt difference basis question can also be asked this year. They can ask you write any 2 differences between the normal salt and then acid salt with one example each. So when you are writing, right, you should include the keyword partial replacement, complete replacement, insufficient alkali, sufficient alkali, right? Acid salt contain a replaceable hydrogen atom, normal salt does not contain any replace. So these are the keywords which you should include in the differentiation, point of difference. Okay, this is one thing. And in page number 48 there are a few acids and salts which can be formed by them can given. So you should remember HCl can form only one type of salt, that is normal. H2SO4 can form 2 salts, one normal and one normal salt and one acid salt. Okay, and phosphoric acid can form 3 types of salt, one normal and 2 acidic salt can be formed by that. And similarly you have the basic salts definition, they will have one replaceable in it. Okay, that's all. I think, yeah, that's all from this chapter. Thank you for watching my video. I'll continue with my video in for chapter number 4 in my next video.